So our objective for today, I can simplify exponential expressions using multiplication properties of exponents. Read together, 1, 2, 3. I can simplify exponential expressions using multiplication properties of exponents. So we already know that, right? Because we introduced that yesterday. But we only covered one property. So in our Fourier model, exponential expressions, by now you should know the definition, right? Because I repeated it like 1,000 times yesterday again. Exponential expressions are expressions. Let's see if you can remember. Write it in there. If you still don't, start writing some examples. Then from there, write a non-example, and then we'll cover that. Go. All right, let's see how you did. Definition. Exponential expressions are numerical and variable expressions raised to a power greater than 1. Anybody come close? Good. Examples. I remember I gave you 2 cubed. Is that correct? X to the 6th. Negative 3x to the 4th. X squared y cubed. Remember that? And then on examples, I gave you guys some equations. And then I gave you guys an expression without an exponent so that we're looking at exponents greater than 1. And critical attributes, we said that it's expressions only and exponents greater than 1. Now the steps, we don't need to write them down because we already know the steps by memory, right? Yeah. Yeah, the steps were step number 1. Identify if the exponential expression is a product of powers, power, product. Damn. Use the appropriate property to compute, and at the end, simplify. So we got these, right? All right, I'm going to move forward. So we got the steps. Yesterday, we covered product of powers property. And by the looks of it in your home plate, it was a piece of cake, right? Just a couple of mistakes here and there, but overall doable. Is that correct? So today we're going to finish the last 2 properties, the power of power and power of products. Okay? So yesterday I gave you guys some practice problems, but this is where I want to address again. Look up to the screen, please. Now, if I was to be a policeman, and I saw somebody running a stop, what would I do? Stop them and give them a ticket or something, right? Because they're running a stop. Have you guys seen anybody run a stop sign or anything? Yeah. Or do like a California row? I mean, not that your parents or anybody in your family does that, right? But they get to a stop, kind of like roll, they're almost stopping, and they just keep going. No? Anyways. This is what some of you are doing with the math that I showed you yesterday. I said, whenever there's a number without an exponent, write an exponent of, write it in there. Don't leave it without an exponent, because later on when we start getting to multi-step expressions, you're going to start making mental mistakes. Please get used to that. Variables, if they don't have an exponent, you're going to write a 1. Same thing with negative numbers. Okay? Properties that we covered, commutative and associative, did we cover those? Yes. So we did something like this. Is that correct? And we came up with a rule that said when multiplying exponential expressions of the same base, add the exponents. And oh, there's my heart. Everybody with me? So we agreed with that. We did some practice. Is that correct? And then something like this. Yes? And then you did plenty of practice on your own. And then we did some of this. I went over one of these in the home plate today, and you're going to do the second one by yourself. Hopefully you got it. But where I want us to get to, yesterday I got to these. Is that correct? That I showed you if 3 to the 0 is 1, and I continue doing that for other numbers, then we conclude that any number to the 0 exponent is 1. Remember that? And then from there, the same thing here. If 3 to the first became 3, then any number to the first exponent is the number itself. Is that correct? If I continue using the different numbers. So write this down. Power of powers property. This is where I want to go. Power of powers property. And we're going to write example Q. Copy this down. Parentheses. 2 cubed, close parentheses, and then outside put an exponent of 4. Underneath that, on parentheses, x to the second, close parentheses, to the 5th power. Underneath that, parentheses, 3 to the 4th power, close parentheses, and outside of that is a 5. Okay, just like the previous property, I'm going to go over the example. I just need you guys to pay attention. Your noodle is going to come up with a rule. Is that correct? All right, here we go. So writing utensils down, eyes up here. Here it goes. So, man, my lines come out really straight. Check this out. If you see it, don't say it out loud. Picture yourself. Copy that. Should already come up with a rule in your noodle. Hold on to that and start thinking what you're going to tell your neighbor in regards to the rule. Copy that. All right. Talk it over with your neighbor. See if they agree with your rule. Fairly simple, yes? Okay, let's put it in a nice definition format. So let's draw a little asterisk, a heart. Aww. All right. So first of all, what's happening to the exponential expression here is being raised to another exponent. Is that correct? Same thing here, same thing here. So let's start a definition. When raising an exponential expression to another exponent. Okay, this is where you're going to help me finish. What was the rule? Yeah.
Keep the base and multiply the exponent?
Keep the same base. Oop. Keep the same base and multiply the exponents. Bam! Pretty good. Oh, right underneath 10Q. And just to clarify, because sometime in the summer I bumped into a teacher before I used to go and show teachers how to do some strategies, and in some of those trainings at the end I would put 10Q, and then she bumped into Mr. Q. I just wanted to tell you, I hadn't seen them in a long time. When you were giving us those trainings, I wanted to strangle you. I'm like, what? Why? You know, because you kept writing 10Q at the end, and I was like, what concept is that? And then I was asking the other people, and they're like, I'm not going to ask them. And they wouldn't want to ask me. I was like, what? Yeah, until Later on, you're like, thank you. You know, the entire training, they were like stressing about it, like, it's just a note for yourself, thank you, and a little happy face. Anyways, I just wanted to clarify that with you guys because I don't want anybody stressing about it. Are we clear? Did anybody go home? What does that mean? Yeah. All right, so with that said, pens down. Now, why does this rule work? Let me show you why it works. Pens down, eyes up here. Look up, please. We know that an exponent tells us how many times we repeat the base. Is that correct? What's inside of the parenthesis? 2 cubed. How many times do we repeat that? Times 2 cubed, times 2 cubed, times 2 cubed. Now, if we use the first property that we learned, the product of powers property, it says if they have the same base, what do we do to the exponents? Add. 3 plus 3, that's 6. 6 and 6, that's, does it work? Yes. Copy that, please. This is called factored form. Now, am I going to ask you to do that every time? No. This is for you to check in case you have doubts of your answer. And every year I tell the students, when in doubt, factor out. I'm telling you, I got this. When in doubt, factor out. So check this out. Is it going to work with this? What is inside of the paren? X squared. How many times do we repeat that? 5x to the second times x to the second times x to the second times x to the second. Same base. 2 plus 2 plus 2 plus 2 plus 2. Does it work? Yes. That's why it works, because if we factor it out using the product of powers property, it works. But the shortcut is the power of powers property. We know that if it's raised to another power, all we have to do is do what? Multiply the exponents. That's why I'm not going to ask you to do this unless you start making mistakes. I'm going to start telling you to do what? Factor it out. Everybody with me? All right. So now that we know the property, let's practice. Copy these. Example 4, A is 5 squared to the 4th power, and B is 4 cubed to the 0 power. You have 30 seconds. Go. Copy that. All right, let's see. Who got 5 to the 8? Yeah, because we multiply these, right? Hold on. 5 to the 8. This one. Who saw 4 to the 0? Okay, who wrote 1? That is correct. Correct answer is 1. 0 times 3 is what? So it becomes 4 to the 0. Is that correct? And what do we know about any number to the 0 exponent? It's 1. Any questions on this one? Yes. That's for negative numbers. Parentheses only for negative numbers. Everybody with me? Let's do another one. Here we go. Copy these. Example 4. Now, don't freak out. I know it looks like a lot, but watch. Look up. Do it by parts. Cover this one or ignore that one for right now and do this one first. Write it here. Then bring the other one down and then do the next step. Okay? Go. 20 seconds. Copy that. Go. Okay, here it goes. I said do it by parts so that you don't get overwhelmed, right? So we're going to do this one first. This becomes x, and we multiply the exponents. That's negative 15. We bring this down. What does this look like? Product of powers. Is that correct? Same base. Add the exponents. This is negative 11. Hands if you got that. Okay, let's move on. Copy this one. And do those, please. You got 20 seconds. Go. Okay. Let's see. This became 320 to the 20th. Hands if you got that. Okay, good. This multiplies, this becomes 6 to the 0, which is 1. We got this? All right. And copy this one. Another challenge one. Let's see how you do with this one. And once again, you copy the whole thing, but you work on this one first, write it underneath, then you do this one, and then do the last step. Go. 20 seconds. Copy that and go. Bam. So let's see. Help me out with this one, please. Go ahead, Haven. What did you do for this part right here? This became what? A to the 12th power. And this became A to the 6th power. And the product of power says that if they have the same base, what happens here? You add them, so this is A to the 18th. Yes? We got this, right? All right? So, write down power of products property. So we already finished yesterday product of powers. Right now we covered power of powers. And right now we're going to cover power of products. Write example Q. Copy this. Parentheses 2x to the 4th, close parentheses, to the 5th power. Okay, writing utensils down, please. Eyes up here. I'm going to go over this again. If you see it, keep it to yourself, please. Let people think. Let their noodle do some work. Man, look at my line, nice and straight. Here it goes. Let's see. Copy that, please. And just to clarify, I'm going to write one more underneath. That's 7 cubed, x to the 2nd, y to the 4th, z to the, give me a number, 6, and all that to the 8th power. So this is just to clarify some of your doubts. Here it goes. So if your rule is correct, then this would be, oh, my bad, sorry. Yes? Okay. Talk it over with your neighbors, please. See what the rule will be for that one. Okay, I heard a lot of, it's like the other one. Who saw this? Let me go back. Who sees that in these, in parentheses, there's only one letter or one number inside of the parentheses? Do you guys see that? And what do you see now on this one? There's more, multiple, right? But do you see how the rule is about the same? Watch. Look up, please. This became 5 times 4, yes? And this is 5 times 1. That's why you cannot forget to put the 1 on the numbers or variables that don't have an exponent. Same here. A times 6, A times 4, A times 2, and A times 3. So for this one, if you just want to say distribute the exponent to all exponents inside the parenthesis. Yes? So for home play tonight, for home play is a play sheet. And I only want you to do numbers 7 only, number 7 through 27 only. And they're up here. Have a good one, guys. Enjoy your home play. See you guys tomorrow.